At the University of Leeds, we are carrying out a research that aims to gain a deep understanding of how biofilter works in UK climatic conditions. And we are doing this through a multidisciplinary approach, including biologists, to look at the interaction between plant, soil, and climate within time. Sustainable drainage systems, SUDS, are a technical solution that manages stormwater at the source, promoting natural catchment processes. Biofiltration systems are one type of SUDS that are particularly suited for pollution control. They consist of vegetative layer and filter layer and an under drain, and their relatively compact footprint, together with the flexibility in design, make them a very promising option to retrofit even in very dense urban areas.
I think the research is helping us to plan particularly for the infrastructure that we're going to develop and implement within the city, so we can use the research on biofilters to make sure that we're implementing the very latest understanding and the right technology, you know, whether we're doing new road schemes, car park schemes, transport improvements. That can all help to manage surface water flood risk across the city, as well as, you know, implementing the infrastructure changes that we need to keep the transport systems flowing in the city.
With these tests we want to experiment different configuration of biofilter that have an engineered media like activated carbon and zeolite, with the intention to optimize the performance. To do so, we are dosing the columns using water runoff from car parks and roads in columns that have the engineered media and columns that without engineered media, and with two plants that have different root system, and we try to understand what is the effect of the engineered media on the plant growth, for example. So we find out that different UK climatic conditions do affect the performance of these systems. For example, in the northwest with high rainfall, we might want to have systems that infiltrate the water much faster, or have a greater biofilter to impermeable area ratio. We also have a deeper knowledge of how biofilter works, and we know that this system can work well in Leeds environment and control heavy metals and nutrients. For example, for phosphorus, with different media and introduction of plants, we can achieve removal performance of phosphorus from 30% up to 80%, and for heavy metal removal it's higher than 90%.
The university can take real advantage from research like this that has used the campus as a testbed, because our sustainability strategy as a university really steers and drives us towards both building the knowledge and capacity of our staff and students and the community around the university, but also things like enhancing biodiversity and managing the water, be that through water runoff or water quality. The biofiltration system that we've tested here allows us the opportunity to pilot such systems on, be that new developments across the campus and the wider estate, or whether it's areas where we're looking to enhance the area anyway to improve biodiversity and amenity value.